Is doing derivatives always easier than doing integrals? A lot of people will say yes, but I don't think so. I totally believe that derivatives deserve more love. So in this video, I'm going to give you guys an example. We will integrate it and then we will also differentiate it, and you guys can tell me which one is easier. So check this out. First off, let's take a look at the integral of 2x times sine to the third power of x squared. Assume we're done? No, not yet. Times cosine of x squared. Yes, this is the function, and of course we have the dx. In fact, for this integral, we can just do this in our head. Do a u sub in our head. Let u equal sine of x squared. Because we know that the derivative of sine of x squared is cosine x squared, and then use the chain rule, the derivative of x squared is 2x. So in fact, we just have to integrate u to the third power in the u world. So we will just get 1 over 4 u, which is sine, and then to a fourth power, and then x squared, and we're done. Look, we can totally do this in our head, even though this looks pretty crazy, right? But what if we have to differentiate? Ready? 2x times sine to the third power of x squared times cosine of x squared. Alright, can you guys do this in your head? How do we do this in your head? Is doing derivatives always easier than doing integrals? I don't think so now, huh? Alright, so of course I'll take care of you guys. Let's do it. First off, this is the product of this, and that. Oh my god. So we will have to use the product rule for three functions, and this is how it goes. Here we go. We will differentiate the first function. So I'm just going to write it down right here in red. Derivative 2x just 2. And then we'll keep the second and third, which is sine third power x squared times cosine of x squared. That's the first part. See, told you derivative is harder. Alright, next one. We are going to keep the first and also the third function, but we differentiate the middle. So I will just write it as 2x, and then differentiating sine to the third power. Wow, we bring the 3 to the front, so we multiply the 3 right here. Actually, I'm going to just write it down like this to make it clear. So we have the 2x, and then we multiply by 3 sine, and of course 3 minus 1 is 2, and then the input stays right there, x squared. And then don't forget we have to differentiate the sine, which will get cosine, and then the input is x squared. And then we will have to differentiate x squared, which is 2x, right? Chain rule. Yeah. And then don't forget we will have to multiply by the third function it stays, which is the cosine of x squared. Yeah. Okay. The third part is we are going to keep the first and also the second, and we will differentiate the third. So we are going to add 2x sine third power x squared, and then the derivative of cosine is negative sine, and then the input stays right here. And of course, we multiply by the derivative of the input, which is going to give us 2x. Wow, look at that. Look at that. And let's see how we can simplify this. I'm not a big fan of factoring things out, so I will not do that. Perhaps we'll just do the most important part, namely 2 times 3 and then times 2, things like that. Just clean things out, yeah? So here we go. This is the answer. First one stays, so that's nice. We have 2 sine to the third power of x squared times cosine of x squared, done deal. And then 2 times 3 is 6, and then times 2 should be 12. So we add 12 and then x, right? So x squared. And then sine squared of x squared. I know some of you guys will say, hey, use the logarithmic differentiation, but you know what? That's just as hard, harder than this. Right? So whatever you want to do. But anyway, what was I? Where was I? Oh yeah. Told you this is hard. Oh yeah, cosine. So we have cosine square of x squared. All right. Let me make this look better for you guys. So that's the second part. And lastly, we have the 2 times negative times that, which is negative 4. And then we have the x squared. Yes. And then sine to the third power times sine to the first power. Here we have sine to the fourth power, and then we have x squared. I hope this is not wrong. Well, if it's wrong, I can prove my point, because for sure this is not wrong. But if this is wrong, that means I didn't get it right. Oh, that's of course. If this is wrong, that means this is harder. That's why I didn't get it right. See? So I kind of hope that this is wrong, so that I can totally prove my point that, hey, is derivative easier than integrals? Right? Please say no. Right? Please say no. So if you're calculus teacher, or if you're calculus students or classmates, if they think derivatives are easier, then no, please show them this video. Anyway, this is another video in our series. We are going to differentiate anything, right? So let me know what should we differentiate next. That's it.